All right, we want to look at one last illustration, I guess, or example of graph of a function. And in the last video, we looked at a graph of a function and obtained information about the function from it. I like to ask these sort of questions where instead I give you information about the function and then you sketch a possible graph. A lot of times these type problems there's not a necessarily unique answer, and I'll explain that, but there are some criteria that have to be the same for everyone that sketches the graph. Now I'm going to sketch this graph. I'm using pens to sketch just so that the it shows up really good when I'm doing these videos. I would encourage you probably to sketch with a pencil, because no doubt as you're adjusting your graph you're going to have to do some erasing to redraw the graph correctly to meet the requirements. And first of all, when we look at a graph, first thing is we're going to sketch the graph of a function. Let's stop there, function f. First of all, that means the vertical line test we talked about, right? Any vertical line I draw must hit the graph at most one time. If I draw any vertical line and I hit your graph 2 or more times, you don't even have a function. You don't have y as a function of x, and therefore that would be really bad, right? You wouldn't even have a function. So make sure that that's not the case. Also, the domain of this function I want to be all real numbers. So that means that every vertical line will hit the graph exactly once. Every vertical line. Of course, in the window I've given here is from what x equal -5 to x equal 5. That's the only part that we're going to be able to see. You do want to bring your graph to the edge of the graph, either to the sides or top or bottom, to indicate that it continues. You don't want to have it stop. Be drawing it up here and have it stop at 4 or something. We're going to satisfy all these conditions. It's going to be a domain of all real numbers and satisfy these conditions. And again, the best thing is just keep it simple. And there's lots of ways you can draw the graph. But don't try and impress me or anyone by your fancy graph. Just make sure it meets these requirements. Okay, so let's see. There's basically, if you look, a list of 5 things. Okay, the first 3 are pretty easy to illustrate. F of 0 is equal to 4. That means when the input 0, the output must be 4. So that tells me there's a point on the graph. And so input, remember, is on this axis when x is 0, so that's right here. Y is 4, 0, 4. In fact, this point right here at 0, 4 is a point on the graph. That's also the y-intercept for the graph of the function. So I know there's a point there, so I'm going to indicate that point. F of 3 is -2, so input 3, output -2. So input is 3 now, so that's x equal 3. The output is y equal -2. So this is a point on the graph as well. And then the third condition, f of -2 is equal to 1. So when x is -2, the y value is equal to +1. Okay, so that gives me 3 points. I'm a long way from sketching the function whose domain is all real numbers, because every vertical line has to hit the graph at least once. And right now I only have 3 vertical lines hitting the graph, right, at each of these points, these 3 points. Okay. So now what do we do? Well, now we're talking about the function is increasing or decreasing. We just need to match this up right. So the function is decreasing on the interval from -3 to -2. Remember, these are domain values here. So from x equal -3 to x equal -2, and then union or what? X equals 0 to 1. So from -3 to -2, right, we've got to be going, what? Down. The function's got to be decreasing, which means as x varies from -3 to -2, the functional values are getting smaller. So if I were drawing that, I could I just want it to be going down. Now there's lots of ways I can do this. I'm going to keep it simple. I'm just going to draw a sort of a line segment. If you want some curvature to it or whatever, that's fine. But there's my curve. Okay. Again, if you have a pencil, that would be a good idea in case you need to make a mistake or something, or you need to adjust it a little bit. And then also from 0 to 1. Remember, these are x values again. So from x equals 0 to x equal 1, on that interval, the function's going down. Now, keeping it simple, again, notice I made it decreasing down to this point. Okay, that's what you need to do. So same thing here, from this point that we're given, we're going to decrease down. Okay, but I'm going to hold off a minute. I mean, if I had a pencil, maybe I would sketch it in. But again, as I said, you might want to erase, and I know something's going to happen, so I'll explain here in a minute. But I'm going to draw that line eventually, or that curve going as a decreasing function on the interval from 0 to 1. Okay. On these other intervals from negative infinity to negative 3, from negative 2 to 0, and 1 to infinity, the function's increasing, meaning it's going up as we go from left to right, right? Functional values are getting larger. So first of all, for values less than negative 3, so that's good. From negative 3 to negative 2, we said it was decreasing. There it is. For values less than negative 3, that's from negative infinity all the way up to negative 3. It's got to be increasing, moving up, right? So what I want to do is I want to come from the edge of the graph here, and I want to just go up. And I'm going to do another line segment here up to there. Again, if you want some curvature to the line where it's curving, and then here I've got sort of a sharp turn here. You might want to have a more smooth turn. If you think about, some of you remember graphs of parabolas, right? And so have somewhere like a parabola there. You can have some curve to the graph as long as it's increasing as we go from left to right on the interval from minus infinity to negative 3. That's good. And by bringing it to the edge, right? Don't put a dot or open circle, because that indicates it's going to continue on. If you want to go ahead and even emphasize that with an arrow, that's fine. But again, my graphs, right, if they come to the edge, that means the trend is that they will continue forever in that direction. And so we're going to be increasing always for values of x less than negative 3. Then from negative 3 to negative 2, again, as we said, we're decreasing. Then from negative 2 to 0, we're increasing. So what has to happen? We've got to go up, and we want to come up to this point. So again, I'm just going to make a line segment connecting these points. If you, I've got a little curve, I guess, to that. And you can have some curvature, right? I mean, it could have it more like a polynomial function where we were going up and down with some curvature. That's fine. And then notice, so from x equal negative 2 to 0, we're increasing. And then from 1 to infinity, for everything greater than 1, we've got to be going up. So here's why I held off on the previous interval where we're decreasing from 0 to 1. If I've got 0 to 1, I bring it down to x equals 1 right here. Here's x equals 1. It brings it down. And then what? From 1 on, I've got to be increasing. There we say we just bring that. Well, what happens is you can't go all the way and cross this vertical line at x equals 3, because you always have you already have a point down here, right? So I can't have a point up here. Otherwise, it would fail the vertical line test. And you can't say, well, let me just put maybe put a hole in the line. I mean, you could put a hole in the line. That would make it a function still. But the problem is it technically would not be increasing on the interval from 1 to infinity, because we're going up, going up, going up, and then all of a sudden, right before we get there, we jump all the way down here to that point. So that's going down, right? It's a decrease, and then back up, and then continue. So what do I really need to do to make this as simple as possible? Well, from 0 to 1, I'm decreasing. I need to make that a steep decrease, steep enough so that what? I drop below y equal negative 2, so that from 1 to infinity, I can be going back up to that point. So I'm going to make this come down very steeply. So now I know how steep. Before I just going to bring it down just a little bit. I'm going to bring it way down here, right? So that now, from 1 to infinity, from this point on, I can increase and I can nicely pass right through the point I need to pass through and continue on my merry way to the edge of the graph. I'll put an arrow there to continue, right? And there's my graph. Okay, so mine's got very choppy, almost like line segments with sharp turning points. That's fine. If you have one that's a little more smooth with more like a polynomial function and so on, you can do it that way. Again, all I'm going to do is make sure when I look at your graph that it passes the vertical line test. Every vertical line hits the graph exactly one time, because the domain is all real numbers. You're bringing the graph to the edge, right? However, and then f of 0 is 4. I make sure the point 0, 4 is on there. F of 3 is negative 2. I make sure the point 3, negative 2 is on there. F of negative 2 is 1. Right, so negative 2, 1 is on there. I'm just checking these off. It's decreasing from negative 3 to negative 2. It's going down. From 0 to 1, it's going down. Good. Between x equals 0 and x equals 1. And then increasing on these intervals for all values less than negative 3, from negative 2 to 0, and from 1 to infinity. I'm just going to go through and check that off. So again, how far you come down here and the steepness of your line slopes or your curves, that can vary as long as these criteria are met. Okay, so you'll get plenty of practice on that, and we'll be doing this more later on as we learn calculus.